Good afternoon, everyone. I'm Andrew from the Technology Department, and I'll be sharing on the challenge on utilizing byproducts from carbon capture. To start off, here are some more background on this challenge. Sustainability has always been at the core of PUB's work. As the world grapples with the impact of climate change, PUB is also doing our part to ensure that our water supply remains sustainable. In line with Singapore Public Sector's target under the GreenGov.sg initiative, PUB aims to achieve net zero emissions by around 2045. To achieve this goal, PUB has a three-pronged strategy comprising of replacing, reducing, and removing carbon. Under the replace strategy, we are replacing carbon-emitting fuels with solar energy. PUB has progressively deployed solar systems on the rooftop of our installations and on our reservoirs. For the reduce strategy, we are looking to reduce our carbon emissions by improving energy efficiency of our existing processes and reducing water demand. This includes reducing desalination energy, achieving energy self-sufficiency for our used water treatment, and reducing water demand. With the implementation of the initiatives under the replace and reduce strategies, PUB is still left with emissions that need to be addressed. As such, we have the last strategy on removing carbon for the environment through technologies that can be integrated with PUB's operations. Under this strategy, PUB is exploring with partners on technologies to capture carbon dioxide in seawater and locking it in precipitates, which could potentially have valuable industrial applications. One of the projects we have is with Sea Change, a startup from the University of California, Los Angeles. We are exploring with them on the use of electrolysis to capture CO2 in seawater to form precipitates and hydrogen, as well as a softened stream of seawater which can be desalinated at lower energy. Through the electrolysis process, CO2 is captured by calcium in seawater to produce calcium carbonate, and magnesium in seawater is transformed into magnesium hydroxide, which can then capture CO2 from the atmosphere. Calcium carbonate and magnesium hydroxide are the two compounds from this project that we are looking for applications in this challenge. We are currently working on a pilot trial with Sea Change at our Tuas R&D facility. The pilot system has a CO2 removal capacity of 50 to 100 kg per day. The byproduct streams from this pilot could be available for the study of the proposed application in this challenge. Through the technologies that PUB is currently investigating to capture carbon dioxide with seawater, large quantities of byproducts will potentially be available. Based on calculations, they include 1 kg of calcium carbonate and 4.6 kg of magnesium carbonate, or 3.2 kg of magnesium hydroxide per cubic meter of seawater. These materials are valuable resources that we are looking to recover for industrial and commercial use in this challenge. We are seeking partners to work with who can identify and demonstrate how these materials can be used in the most economical and environmental friendly way, especially in Singapore's context. Here are some key considerations that you should think about when coming up with a proposal for this challenge. The precipitate byproducts from the CO2 capture and removal technologies that PUB is currently exploring would be recovered from the process by sedimentation. Hence, the streams would be in the form of slurry, which have high water content of above 50%. Note as well that the water would be saline seawater. Another consideration is that seawater naturally contains other minerals like potassium, aluminium, iron, silicon, and so on. Therefore, the slurry may also contain these materials or other compounds which may be formed during the CO2 capture and removal process. Depending on the proposed application, additional treatment processes may be required to remove these materials and unwanted precipitates for the necessary solid purity to be achieved. This should be considered in the proposal. In addition, as the slurry has a high water content, treatment of the slurry may be required prior to transportation of the resource to other locations for use or further processing. Again, the requirements for this should be included in the proposal for this challenge. For your proposed application, there could be existing regulatory requirements and standards that need to be complied with. For example, if the application is for building construction, there would be standards relating to leaching, compressive strength, and so on to follow. How these standards will be met should be articulated in the proposal. If those standards are currently present, the proposal should mention what needs to be done to develop the necessary standards. Another consideration is that proposed application should ensure that the original intent of the carbon capture is sustained. For magnesium hydroxide, it would need to capture CO2 permanently while it is being used in order for carbon abatement to be achieved. Hence, applications related to the use of magnesium hydroxide need to incorporate the function of CO2 capture, and the amount of CO2 that can be captured per mass of magnesium hydroxide should be mentioned in the proposal. For calcium carbonate and magnesium carbonate, The proposed application should not cause CO2 to be released from the carbonates, and the permanence of the CO2 capture in the carbonates should not be compromised. Here are some of the known applications of calcium carbonate and magnesium carbonate or hydroxide. The most common use thought about is construction materials. Others include fertilizer, food additives, and consumer products. We are open to solutions in these areas as well as other applications not shown here. Moving on to the expected outcomes, we are looking at the proof of concept to apply the recovered byproducts through lab scale or pilot trials over a period of up to 18 months. The trial could make use of slurries containing approximately 15 to 25 kg of calcium carbonate and 50 to 80 kg of magnesium hydroxide per day from PUB to demonstrate the feasibility of the proposed application. Techno-economic analysis will need to be done at the end of the project to show that the application is economically viable. Lastly, here are some of the details you should include in your application. Your proposal should highlight the technical merits of the proposed application and how the byproducts recovered in the form of slurries would be utilized or treated and processed to the required purity to meet the standards and requirements for the proposed application. The quantity and demand for the proposed product should be assessed in the proposal as well to show that there's a need to go into the proposed application. A techno-economic analysis taking into account capital costs, operating expenses, and revenue should be included. It should also cover the scope from slurry to transportation, additional treatment, and final product or application. That is all for my presentation. We look forward to receiving your proposals which will help PUB to better utilize the byproducts and achieve greater sustainability as we move towards our target of net zero emissions. Thank you.